All right, let's do some problems here. So find x. So I know I'm looking at a right triangle here. And across from the right triangle is the hypotenuse. Leg 1, leg 2. Doesn't matter which one we call leg 1 and leg 2 at this point. The Pythagorean theorem says L1 squared plus L2 squared equals hypotenuse squared. So now I plug these values in, and I'm going to find x. All right, so this is not a yes or no question. This is find those values. So 15 squared, that's 225. 20 squared, that's going to be 400. Now I add those together. That gives me 625 equals x squared. Now I take the square root of both sides. So square root of both. So x is 25. All right, over here now we're looking at the hypotenuse, leg 1, leg 2. So I write that into my equation. 5 over 17 squared plus x squared equals 13 over 17 squared. So one quick trick I can do is I can find that my answer x equals something over 17. We'll call it y over 17. I'm just going to switch this equation because the denominators are the same to just 5 squared plus y squared equals 13 squared. Once I find that, I'll put it over 17. That'll be my answer. So 25 plus y squared equals 169. I subtract 25 from both sides. So y squared equals 169 minus 25. Y squared equals 144. Now I take the square root of both sides, and y is 12. So I plug that in now. So x is 12 over 17. Alright, so this is just a simple Pythagorean theorem problem. The difficulty comes when we look at fractions. Alright, next, that's the hypotenuse, leg. It says determine whether each set of numbers A can be the measure of the sides of a right triangle, and I'm going to circle yes or no for that. And then B forms a Pythagorean triple, yes or no. So these are whole numbers. So if they do make, if they are the measures to the sides of a right triangle, then they would be a Pythagorean triple. So let me write this. 7 squared plus 9 squared equals 13 squared. I'm trying to find out, is that true? So 7 squared, that's 49. 9 squared is 81. And 13 squared is 169. If I add these two together, I get 130 equals 169. That's not true, so no. And because it's not the sides of a right triangle, it's not a Pythagorean triple. Next, hypotenuse, leg. So the square root of 54 squared plus the square root of 46 squared equals 10 squared. Is that true? So that's just 54, that's 46, that's 100. If I add those up, in fact, it is true. So yes, that is, they do form the sides of a right triangle, but because these aren't whole numbers, no, it's not a Pythagorean triple. Moving on now to 18 and 19. Special right triangles. Let's remember here, in a 45, 45, 90, the hypotenuse equals the leg times the square root of 2. So for 18, x is the same as this leg, so x is 9, and y is the leg times the square root of 2, so 9 square root of 2. That's it for 18. For 19, I know L1, L2 is y, and the hypotenuse is x. So let's remember this. The hypotenuse is 2 times L1 And L2 is L1 times the square root of 3. So, to find the hypotenuse, x equals 2 times 6, so that's 12. And y equals 6 times the square root of 3. Alright, so for number 20 and 21, I redrew the diagrams right here. And I put the values in that you're given. So 18. And I'm asked to find A and Z. So what you need to recognize is that this yellow triangle up here, that's a 30, 60, 90. This is also a 30, 60, 90. So I can use those pieces of information to help me. So this is L1 of the smaller yellow triangle. So Z is the second longest leg. So that's going to be L1, or 18, times the square root of 3. Now to find A, I'm looking at another triangle now where I know that Z right here is 18 square root of 3. So that's the hypotenuse, the shorter leg. So if I double it in this pink triangle, that's 36 square root of 3. Alright, same idea here. I can work my way around. I'm going to use the pink triangle first to find Z. So Z is the shorter leg. So let's remember L1, or L2 is L1 times the square root of 3. So I want to divide this by the square root of 3 to figure this out. So that's 14 divided by square root of 3, which equals 14. That's Z. A now is just double this. So that's 28 square root of 3 over 3. Y is, and this is the shorter leg of this triangle, so I'm going to divide Z by the square root of 3. So 14 square root of 3 over 3 divided by the square root of 3. So these cancel out, so that's just 14 over 3. And then B is the hypotenuse, that's twice the shorter leg. So 2 times 14 over 3, that's 28 over 3. And then the last one, number 22. To create a bird, Michelle first folded a square piece of origami paper along the diagonals. If the diagonal measures 8 centimeters, find the length of one side of the square. So what they're saying is that this diagonal is 8 centimeters. That makes a right triangle, and those are congruent sides because that's a 45, 90. So these are congruent. X, Y, these are both the same. If I find one, then I found the other. So remember, the hypotenuse is the leg times the square root of 2. So 8 equals x times the square root of 2. Those cancel. Now I multiply both sides by, or top and bottom, by the square root of 2. All right, and that's the first page.